So moving to the next one, 11th question. Two charges each of 1 coulomb. How many charges? Two charges. How much value? 1 coulomb are at a distance of 1 kilometer apart. So you are given two charges which are kept at a distance of 1 kilometer apart. The force between them is. That's it. So very clear. So the force between any two charges is given by K Q1 Q2 upon R square. This is the general formula, and the value of K is 9 into 10 power 9. Each charge is given as 1 coulomb. So 1 into 1 upon distance is given as 1 kilometer. So 1 kilometer is nothing but 1000 meters in SI units. So 1000 whole square. Hence, the value of f is found to be 9 into 10 power 9. 1 into 1 is 1 upon 1000 is 10 power 3. So, 1000 into 1000 is 10 power 6. So, further simplification gives f is equals to 9 into 10 power 9 into 10 power minus 6. 6 going to the numerator will become 9. 10 power minus 6. Hence, the value of f is found to be 9 into 9 minus 6 is 3. 9 into 10 power 3 newtons. So, the value of f is found to be how much, children? 9 into 10 power 3 newtons, and hence the correct option is option A, that is 9 into 10 power 3 newtons. Got it? So moving to the next question, that is 12th question. Two charges plus 2 coulombs and 6 coulomb, two charges are repelling each other. Of course, because they are same charges, they are of like charges, they repel each other with a force of 12 Newton. Now, force is given, coulomb, two charges are given. If each charge is given minus 2 coulomb of charge, then the value of force will be. First of all, let us try to find out the initial force acting between them. The initial force is equals to K times of Q1, Q2. Q1, Q2 is 2 into 6 by some distance square. And this value itself, they gave it as 12 Newton, simplified value. So, from this, we can find out the value of K by R square into 12 equals to 12 Newton, or K by R square is equals to 1. Keep it aside. So, K times of 2 into 6 by R square is 12 Newton, 2 into 6 is 12. So, K times of 12, K by R square into 12 is 12 Newton, or K by R square is equals to 1. So, now moving to the next one, if each charge is given minus 2 coulomb. So, for the second case, in order to find the value of F2, same formula K into Q1. So, when the charge plus 2 coulombs is given a charge of minus 2 coulombs, then how much is it? 0. Similarly, the second charge, where is that 6 coulomb, is again given minus 2 coulomb, the net charge will be plus 4 coulomb. Hence, the net force in this case will be K times of Q1, Q2, that is Q into 4 coulomb upon distance square, R square. How much you are asked to find out? Of course, we just found the value of K by R square as 1. So, F2 is equals to 1 into 0 into 4. Finally, it is 0. Hence, the final answer is found to be 0. The final answer is found to be 0. So, whenever a charge of minus 2 coulomb is added to the given values, the net force is found to be 0. Got it? So, moving to the next question, 13th one. 3 equal charges are placed on the 3 corners of a square. So, first of all, so they were given us a square. So, on the square, Three equal charges are placed on the three sides of a corner. So let us suppose this as first corner, second corner, third corner as well as fourth corner. So on the four corners, three charges Q, Q, Q are kept. If the force between Q1 and Q2 is F12, so Q1 and Q2 equal charges. Suppose that if it happens to be positive, all are positive only. Between the two charges, force of repulsion takes place and the direction will be something like this. And this force is given as F12. Okay. And let us suppose that the square is having a side A. So this is also A, here also A, here also A. The value of F12 is found to be 1 by K times of Q1, Q2. That is Q square upon the distance between them is A square. K, Q1, Q2, Q square upon A square is the value of F12. Similarly, that between Q1 and Q3, where is Q1? This is Q1 and Q3 is this thing. The force between Q1 and Q3 is F13. So again, positive, two positive charges. Force is given as F13. This is also repulsive force. Similarly, the value of F13 is found to be K times of Q1, Q2 is again Q square upon the distance between these two is, here is A, here is A. So this must be equals to A root 2, applying Pythagoras theorem. Root over A square plus A square. So that is equals to root over 2A square. So hence it is nothing but root over 2A square is root 2 into A. So A root 2. So this value is found to be A root 2 whole square or KQ square by 2A square. That's it. The ratio of magnitudes of F12 upon F13. They are asked to find out the value of F12 upon F13. F12 is KQ square by A square. F13 is KQ square by 2A square. Simplifying all, we have K gets cancelled, Q square gets cancelled, A square also gets cancelled. So finally you are left with the numerator, nothing is there, 1 upon 1 by 2. Simplifying, you will get it as 2:1 or 2 or simply 2. Okay. Hence the correct option is option B, that is 2. Okay. So moving to the next question, 14th one. Two charges Q1 and Q2. How many charges? Two charges Q1 and Q2 are placed in vacuum at a distance D. So where is it kept? In a vacuum. And the force acting between them is F. If a medium of dielectric constant, whenever it is kept in a medium, so epsilon M is equals to K times of epsilon naught, and that K is called as your dielectric constant, indicated with the letter 4, given by the value 4, and is introduced around them. The force now will be, well, so children, whenever a dielectric constant is being kept, so let us discuss in detail regarding this. So how many charges are there? Two charges, one is Q1, the other is Q2. So where is it kept? Placed in a vacuum at a distance D. Now the force acting between them, F, can be written as K times of, okay. In air, if you consider, this is all about your air. In air, it is epsilon naught. So value of F is given as, the force between them is indicated by F, equals to 1 by 4 pi epsilon naught Q1 Q2 by D square. Similarly, the same if it is kept in medium. The second case, when the same values are kept in medium, then we have the new force, say F2 or F dash, anything, given by 1 by 4 pi K epsilon naught, medium, 4 pi medium epsilon M Q1 Q2 by D square. but epsilon m is taken as k epsilon naught, hence f dash is equals to 1 by 4 pi k epsilon naught q1 q2 by d square. Okay, where the value of k is given as 4. The force now will be, so in order to find out the new force, let us try to divide the two equations. Let this be first equation and this be second equation. So dividing equation 2 with equation 1, let us see what happens. Equation 2, f dash, equation 1, f equals to, here we have 1 by 4 pi epsilon naught q1 q2 by r square whole upon second equation 1 by 4 pi k epsilon naught q1 q2 by r square. First equation we have 1 by 4 pi epsilon naught q1 q2 by r square. Simplifying these two carefully, we have 4 pi gets cancelled, epsilon naught gets cancelled, q1 q2 gets cancelled, r square also gets cancelled. So now you are left with numerator, nothing is left, so 1, and denominator we have, numerator we have 1 by k and denominator is 1, so finally we have 1 by k. So clearly f dash by f is found to be 1 by k, or f dash is equals to f by k. So bringing the f the other side, we have f by k. But the value of k, dielectric constant k, is given by 4, hence it is f by 4. So the correct option is option D, that is f by 4. So whenever a dielectric constant of 4 is kept between the two charges, then the new force will become 1/4 of the previous value. Okay. Now moving to the next question, that is 15th question. Force of attraction between 2 point charges q and minus q separated by d meters is Fe. So initial force of separation, force of attraction or attraction between the two charges which are separated by distance d is given by Fe. When these charges are placed on two identical spheres of radius 0.3 d, whose centers are apart, the force of attraction between them is. Let us try to understand this in detail. So, force of attraction between 2 point charges, one is q and the other is minus q, and which are separated by distance d. The force of attraction between them is given by k times of q minus q upon d square, and this is indicated with the letter Fe. When the charges are placed on two identical spheres, so one sphere so two spheres they have considered one sphere and second sphere. So now these charges are placed on two identical spheres. One charge they named it as q, the other charge is minus q. No doubt, even though they are kept at a little far away distance, because of opposing charges, they both attract each other. As a result, the charge will attract each other and they will be separated by certain distance, which is a distance of its diameter. So this diameter is given as 0.3d. This diameter is also given as 0.3d. Now the new distance of separation is 0.3 plus 0.3 is 0.6d. The new distance is given as 0.3d plus 0.3d. Totally it is equals to 0.6d. Hence, the new force of attraction, some F dash, can be written as k times of charge q minus q separated by a distance 0.6d whole square. The force of attraction between them is whether you have greater than the previous one, lesser than, equal to that, less than, anything we have to find out. So let us try to find out this. It is equals to K Q times of minus Q upon 0.6 whole square is given as 0.36. This is D square. So as we know that the value of K Q minus Q by D square is indicated by Fe. Hence, the final value will be 1 by 0.36 times of Fe. Or this can also be written as 100 by 36. In order to remove the decimal, that is 0.36, we have to divide it. It can be 0.36 can be written as 36 by 100. 100 it is taken to the numerator, 100 by 36 times of Fe. Okay. Or the further values gives, this is 18, 50, 25 and 9. So 25 upon 9 times of Fe. Or this can also be taken as 9 2s 18, 70, 70 means 9 7 9 7 63. Okay, something like this. So clearly the new force F dash is found to be 2.77 times of Fe. That means it is increased. So clearly its value is greater than the previous value Fe. Hence the option must be option A, that is how much, children? Greater than that of the value Fe. Hence first option must be true. Over. So moving to the next question, that is question number 16. The value of electric permittivity of free space is, as we said that the permittivity of free space is indicated with the letter epsilon naught. In vacuum, its value is found to be 8.85 into 10 power minus 12 Coulomb square per Newton meter square. So 8.85 into, where is that value? 8.85 into 10 power minus 12 Coulomb square per Newton meter square. So no doubt option C must be true. So 8.85 into 10 power minus 12 Coulomb square per Newton meter square. Clear? So this is the value which we have already discussed in the concept. Moving to the next one, that is 17th question. So what it is given is two similar spheres having charge plus q and minus q are kept at a distance f. Okay, let us assume this. So two charges, similar charges. Okay, so one charge they have considered it as plus q, the other charge is given as minus q, kept at a certain distance. So unknown distance they were kept, say d, and the force of attraction between them is given as F. If in the middle of the two charges, another similar sphere having plus q charge is kept, then it experiences a force in magnitude and direction as. So how much force is being acting? So suppose if a new force, say another sphere, okay, whose charge is given as plus q, then it experiences a force in magnitude and direction as. So we have to find out the magnitude as well as direction. So let us try to discuss the same. So between the two charges, some force is acting. Okay, so let us indicate that force is F1, and between the two charges, some another force, that is F2. So the total charge is given by K times of force between them is equals to Q square by D square. Another sphere having charge kept middle. So the distance here is D by 2 and here also D by 2. So this value is something around D by 2 whole square plus between the two charges. Again what happening? Clearly only magnitude if you consider, magnitude of the forces acting between them is K times of Q1, Q2 by D square. So, Q1, Q2 is again Q square upon D by 2 whole square. Regarding direction, we shall discuss later. We only consider the magnitudes, only charges, how much value, Q square, Q square. Regarding the direction, which direction we shall discuss later. So, this net force will be equals to KQ square by D square by 4 plus KQ square by D square by 4, and this 4 will become up, means 4 times of KQ square by D square plus again 4 KQ square by D square, and the total magnitude is found to be 8 times of KQ square by D square. But previously, when this charge was not kept, there was just a force F between only these two charges, and that magnitude of the force is given as again KQ square by D square. So, clearly we can say that this value is equals to 8 times of KQ square by D square, that is 8F. So, the magnitude of force between the new charge when it is kept is found to be increased as 8 times of the previous charge. So, 8F. So, the answer may be either second one or third one. In order to find out the direction, let us discuss again in detail. So, first of all, between these two charges, positive charge and positive charge, no doubt there exists a force of repulsion. This is sent to the other side. It pushes the charge. And between the positive charge and negative charge, there exists a force of attraction. As a result, because of this charge, it is again pulled in this direction. Together, the charge is pushed towards the right side. So, right side means towards the negative charge. So, 8F force towards negative charge. Hence, option C must be true. So, it experiences a force of 8F. It experiences a force of 8F towards which charge, children? Towards negative charge. Hence, third option must be true. The correct option is third option C, that is 8Q. Let me recorrect it. A charge. Yes. So, what is given? A charge Q is divided into two parts. One is small q, the other is Q minus Q. If the Coulomb repulsion between them, when they are separated to be maximum, the ratio of Q by Q, this we have already solved in our previous problem. Okay, but still let us try to find out the same. So, what is given is a charge Q is again divided into two parts. Okay, so what is given? One is Q, the other is out of the total charge Q. So, the remaining must be equals to out of Q minus Q. So, this is the leftover part. Okay. So, what is Q? Q plus Q minus Q, small q minus Q gets cancelled, leftover is Q. Okay. So, the whole charge is given Q, some portion is Q, the remaining portion is Q minus Q. This is what they have given. If the Coulomb repulsion between them when they are separated to be a maximum is. So, what is the force of acting between them is given as F is equals to K times of Q1, Q2, that is first charge is Q, the next charge is Q minus Q upon the separated by some distance. Okay, let us separate it by some distance, say R square. Okay, now they said that for maxima condition, the force must be maximum. Okay, when they are separated to be a maximum distance, Coulomb repulsion between them. Okay, we have D for condition for maxima is dF by dQ must be equals to 0. dF by dQ must be equals to 0. That means derivative of force. How much force is that? F value is KQ times of Q minus Q by r square must be equated to 0. So clearly k and r square are constant. So k by r square into derivative of this value q into q minus q must be equals to 0. K by r square, if you bring to the other side, that will become reciprocal. So 0 into r square by k will be 0. Hence d by dq of q times of q minus q must be equated to 0 in order to find the ratio of q by q. So in order to find out this, let us equate the same. So multiplying q with this, we have a derivative of small q into capital Q is small q capital Q minus small q into small q is small q square equals to 0. Derivative of q into q can be written as capital Q minus derivative of this q square can be written as 2q equals to 0. Our q is equals to 2q. But you are asked to find out the value of q by capital Q by small q. So bringing this towards the left side, you are left with 2. Hence, the value of capital Q by small q is found to be 2. Hence, the correct option is option 1. The answer is 2. Okay. So, is that okay, children? So, q by q is found to be 2. So, moving to the next question, that is question number 19. The question is as said, let me again recorrect this. When air is replaced by a dielectric medium of constant K. Let me write this. When air is replaced with dielectric medium of constant K. When air is replaced with dielectric medium of constant K, the maximum force of attraction between the two charges separated by a distance. So, decreases by K times, remains unchanged, increases by K times, or increases K inverse time. So, we have already solved this question, but still let us check it back once again. We know that in air, the formula is given as 1 by 4 pi epsilon naught. Two charges, say some two charges as q1, q2 and separated by distance r square. Similarly, in the medium, the same value is given as 1 by 4 pi epsilon naught is replaced with epsilon m, and this epsilon m can be given as k epsilon naught q1, q2 by r square. Okay, so now ratios, taking the ratios Fm by Fa can be written as, so what is this value? 1 by 4 pi k epsilon naught into q1 q2 by r square whole upon 1 by 4 pi epsilon naught q1 q2 by r square. Simplifying carefully, we have 4 pi gets cancelled, epsilon gets cancelled, q1, q2, r square gets cancelled. So, finally, you are left with 1 by k whole upon 1. Hence, the value of Fm upon Fa is given as 1 by k, or Fm is equals to F air by k. It is equals to 1 by k times of the force in air. So, clearly, 1 by k times of the air means it is decreased by k times. So, correct answer is decreases by k times, and hence the correct option is option A, decreases by k times, reduction factor. Okay. So, now moving to the next one, that is question number 20. So, here we go. One metallic sphere A is given positive charge, whereas another identical metal sphere B of exactly same mass of A is given equal amount of negative charge. One is given a positive charge, equal amount, another is given a negative charge, then mass of A and mass of B still remain equal. So, you are given charge and now you are asking just to find out the mass. So, let us focus on this carefully, children. So, first of all, one metallic sphere, consider this metallic sphere, let us name this as A, and this is given a positive charge. Whenever an object, okay, or a conductor attains a positive charge, how does it attain a positive charge? By losing some electrons. Whenever a conductor attains positive charge by losing electrons, then the mass reduces because it loses electrons. By losing the electrons, its mass decreases or mass reduces. Okay. Similarly, there was given another conductor, okay, and the name of the conductor is B, and this B, same mass of A, is given equal amount of negative charge. So, now what they gave is, negative charge was given. So, whenever negative charge is given, what happens? Electrons are given to them. So, it gains electrons. So, giving negative charge means it gains electrons. Whenever some electrons adds on this metallic sphere, then what happens? Its mass increases. By gaining electrons, its mass increases, whereas by losing electrons, the body A loses its mass. So, clearly, then mass of A and mass of B still remain equal? No. Mass of A increases? No. Mass of A decreases. Mass of B decreases? No. Mass of B increases. Mass of B increases? Yes. So, the correct option is option D, that is clearly mass of B increases. Hence, fourth option must be true. So, what is the correct answer, children? Mass of B increases. That's it. Well,